Hi, and welcome to Section 4. This is a highly talked about subject in React Native: advanced animations. Throughout this section, we're going to create Tinder-like swipe cards. In the first lesson of Section 4, we'll be focusing on the animated API React Native provides. To start with animations, you'll start with a value. This value is simply a number. An easy example that we'll be using is a view's opacity. We'll want to start with the card being shown on the screen. Therefore, the opacity will be set to 1. If we wanted the card to not be shown on the screen, then we set the start value to 0. There's also a more advanced value xy method that allows the user to work with vectors as opposed to one single value. The animated API has 3 animation types. Most of the time, you'll be working with the timing type. This animates a value over time using easing. Easing is a also customizable module that determines the physical motion of the component being animated. The spring animation replicates the physics of a spring and bounces the component to that desired value. And lastly, the decay method will start off the animation quickly and slow to a stop. All of these methods are highly customizable and fun to play around with. There are 4 animated components that the API explicitly handles in the background. If you wanted to make a custom component animated though, the API also offers the create animated component method. Before I start the code, I wanted to give credit to a great tutorial I found on tutorialscapital.com called React Native Tinder-like swipeable card views dynamically, Android and iOS tutorial. A lot of the code I'll be showing is inspired by this tutorial. You'll see a new swipe deck folder. The file structure is very similar to the card feed. The swipe deck folder contains a container, a presentational component, and a component folder where the card and direction buttons live. Those 2 components are either pure or functional components, and all of the logic will be in the container file. The swipe deck is fairly simple. It's a view that has 3 columns, 2 for buttons, and a middle one for the cards. All the direction button does is render a native base button that it calls the function passed to it and shows the text passed in. This button, realistically, can be used as a shared component, but for now, we'll keep it in the swipe deck. It's inside the card that will be rendering the animated view and passing the animated values from the container. For now, we're only showing a single card, so there's no need to show anything on that card itself. As you can see, we're transforming 2 values. One is the translate x, and the other is the rotate value. In addition to those transforms, the opacity is also being affected by the value that's being passed in. And we'll get to that more soon. It's worth noting that the card style is a little unique. Instead of using the flex view that is so common with React Native, we'll absolutely position the card inside of the container view, which has a flex of 3, and centers all of its items, and then set an explicit height and width. This is done so it can work with the translate x value that is being transformed inside of the card. So now let's just start from the top. The first thing that we do is determine the screen width and set it in the global variable structure. After creating the class, the first 2 values that are set are the animated x value and the animated card opacity. It's important to note that these are not stored in the component state. The purpose of that is to avoid unnecessary re-renders of the component. We want the animated component to do its magic behind the scene and not lower its performance. The next 3 functions are where the magic happens. In the swipe cards function, a multiplier is passed, which essentially denotes whether the value should be negative or positive. A swipe left is negative, and a swipe right is positive. Instead of calling 2 animated timing functions one after another, we want to perform them simultaneously, so we'll utilize the animated.parallel method. The first timing method changes the animated x value from 0, which in this case denotes this card's starting position, to the size of the screen width. The second value is setting the card's opacity to 0, which makes it so the card disappears before our eyes. This will give us an effect of a card sliding off the screen and fading away when we press the button. If you remember though, there was one more value that we're changing, and that's the rotation of the card. We'll use the x value that we're animating and spread that value out between 0 and 20 degrees on a right swipe and 0 and negative 20 degrees on a left one. The interpolation method will map over the input values to give a range of new values. Since we know the x value is going to have a range between the negative and positive device width, we can tell the animated library that when the maximum values are reached, return a string value of a maximum of 20 degrees and a minimum of negative 20 degrees. I find it helpful to play around with the numbers and see what changing them does to get a feel for how interpolation works. Something that's super easy to forget, but you really shouldn't, is to import the new route in your navigator. I made it the initial route too since there is no connection yet between the card view and the list view. For the purpose of this demo, I'm going to make the animations 2 seconds instead of 200 milliseconds, or 0.2 seconds, so we can clearly see the animations at work. Well done! We have a base for a deck card swiper.